Hello all, welcome to this video. Today what we are going to do is we are going to see the data structure syllabus. I'm going to tell you what is the overview of each and every concept that we have got for data structures and the prescribed syllabus for Bangalore University. Okay. What we will do is we'll go to the unit 1. You can see unit 1 we have got 11 hours to finish it. Okay, in the class. You see, in the unit 1, we have got introduction and overview. Introduction and overview, and we have got definition in that. This is a subtopic. You can consider it as a chapter 1. This is chapter 1, which is introduction and overview in the unit 1. Okay. We have got definition of data structures. Here you will learn what is data structure and where we will be using it. And then elementary data organization. It means how the data will be organized in the main memory when a particular program is running. This you will be learning here. And then data structures. What are the different data structures? And what are the operations in the data structure? You will be seeing that they have mentioned some of the operations that can be done on a particular data type. Then abstract data types, and then algorithm complexity. Here you will be learning different notations like big O notation, omega, and theta notations. This will tell how a particular algorithm is efficient than the other. Okay. And then coming to the next one, that is time space trade-offs. And then coming to the preliminaries, this is the second chapter in unit 1. This is chapter 2, the unit 1. Here we'll be having mathematical notations and functions. Some of the important mathematical notations that are required for learning data structure you will be knowing here. And then the algorithmic notation. Here you will be learning how an algorithm can be written. What is the procedure to write an algorithm. And then control structures, complexity of an algorithm. This is mostly related to the algorithm's complexity itself. And then asymptotic notations for the complexity of algorithms. It is the same thing. These are the asymptotic notations, big O, omega, and theta. There are many more. You will learn that once you start learning the concepts. And then coming to the introduction to strings. This is the first kind of data type actually. And storing string, how the strings are stored, we'll be learning that. Then the character data types, string operations like searching in the string, these are operations on string. And then word processing, introduction to pattern matching algorithm. See, word processing you might have seen, like editing the word, editing a text, or in the word processing applications you might have seen so many operations that can be done on the strings. But here you'll be learning very simple using C programming. And then introduction to pattern matching algorithms. There are many pattern matching algorithms. Some of the algorithms you'll be learning here. Okay, this is the first unit. First unit is very basic. Here only about the complexity and what is data structure, and about the strings you are going to learn. Okay, if you see, there are two units there, main two units. In the second unit we are going to have the first chapter, that is arrays, which is the most basic type of data structure that you will be learning. You have got the definition of arrays, and then linear arrays. Arrays as abstract data type, and representation of linear arrays in memory, how they are actually represented in the memory, you will be seeing that. And traversing linear arrays, this is actually operations on arrays. Traversing means going from one element to another element whenever you are processing it. And then inserting, deleting, these are also operations on the arrays. Multi-dimensional arrays, you will be learning like two-dimensional array, three-dimensional array. Two-dimensional array is like the matrix that you will be writing row into column, so that is multi-dimensional array. And then matrices, and sparse matrices. You'll be learning all this when you start learning the syllabus. Searching and sorting technique using array. The searching and sorting, these are also very important when it comes to arrays. Okay, this is what you are going to learn in arrays chapter. Now coming to the next one, linked list. See, in most of the interviews, if you see, the questions will be on the base of linked list. So this is a very important chapter from the interview perspective. Okay, now coming to the definition, you'll be learning definition of linked list, representation of representation of singly linked list. There are three kinds of linked list. One is single linked list, double linked list, and circular linked list. Okay, and here we have got another header linked list. You will be learning all these things. Traversing a singly linked list, how you will be going from one element to another element. Searching in a singly linked list. Memory allocation, how the memory allocation is done in linked list. Most of the time we'll be using heaps in like creating the linked list, and that's why we need to know what is memory allocation. Dynamic memory allocation, you'll be learning that one. And then the garbage collection, whenever you delete a element, how how you will free the memory whenever you use it and finish its work. And then insertion into a singly linked list, this is also an operation. Deletion from a singly linked list. And somewhere you'll be having overview about the doubly linked list, header linked list, and the circular linked list. You can see it is not in detail, but singly linked list will be learning in detail. Okay, that's what was unit 2. In unit 2 you'll be learning two chapters. One is arrays and then the linked list. And then coming to the next one, that is unit 3. In unit 3 you have got mainly two chapters, that is stacks and queues. You can see you have got definition of stack, array representation of stack, means how you will build stack using arrays. Linked list representation of stack, it means how you will build a stack using linked list, because already in the second unit you have learned what is array, what is linked list. And stack has abstract data type, arithmetic expressions, Polish notation, conversion of infix expression to postfix expression. This is also a very, like, you will be learning some of the algorithms which will help you to convert infix to postfix. You will learn what is infix expression and postfix expression once you start learning stacks. Evaluation of postfix expression. Computers systems cannot understand the BODMAS rule, and that's why we'll implement postfix expression and infix expression in using stacks. And application of stacks, recursion, tower of Hanoi. This is also an important concept in stacks. Implementation of recursive procedures by stack. Okay, and then coming to queues, you'll be learning definition of queue. Queue is nothing but like it is a line, first in first out. You learn that. This is last in first out. It is LIFO, and it is first in first out. Whosoever comes first in that line, they will be going out first. But here last in first out. Okay, you learn all these things. Array representation of queues, linked list representation of queues. It means we will be building queues using arrays and then linked list. You can see the same pattern is followed here also. And then types of queues, having another subtopic in this, types of queues: simple queue, circular queue, double-ended queue, priority queue, operations on queues, and applications of queues. You see, simple queue, circular queue means it will be starting and the ending point will be one after the other so that it becomes circular. Double-ended queues, it means you can add and remove the element from both the sides. Priority queue, the, like, adding and removing the element will depend upon the priority of that particular element. Okay, and then operations on queues, like adding, deleting, all these are operations on queues. and then the applications on queues in the real life scenarios. You will be learning that one. And now coming to the last unit, unit 4. For this we'll be having 12 hours. For all other chapters it is 11 hours. Okay, now you see here binary trees. You have got first chapter as binary trees, definition, tree search, traversal of binary tree, tree sort, building a binary search tree, height balance. Here you will be learning AVL trees, height balance. This is also most important concepts. Continuous representation of binary tree, heaps. You see, red black. This is the algorithm, red black tree, and then insertion and deletion, external searching, B trees, applications of trees, and then you will have graphs, mathematical background. This is actually you have studied already. You have studied in the discrete structure chapter. The mathematical background already you know. And computer representation also we have shown how how we'll represent graphs in adjacent matrix or linked list. Okay, we'll be using that one. And graph traversal and hashing. This is another chapter. Hash table as hash table ADT, understanding hashing, components of hashing, hash table, hash function, hashing technique, and what are collisions in hashing, collision resolution techniques. These are the, see, the fourth unit is very important because these are actually higher concepts. But if you can understand this, then you are very comfortable with data structure, especially in the interviews and all. Okay. Now coming to the prescribed textbook by the Bangalore University, you see Seymour Lipsus data structure we see whatever the syllabus is given here in the whatever the syllabus is given here, this book is having everything exactly as it is. Okay, I think I have just seen the book. It is almost the same. You can use it. And there is another book, Data Structure and Program Design using C. You can refer this also, but I recommend using this book because this is explained in very simple language and you can understand it better. And whatever is there in the syllabus, everything is given in this book. Okay. And for having more knowledge about the data structures, if you want to explore in detail, you can go for reference books. And I would recommend this because data structures, if you want to become a web developer or a data scientist, you should know how efficient applications are built. Okay, and for that you can go for advanced studies in data structure using these reference books. Mark Allen Weiss, Data Structure and Algorithm Analysis in C, and a structured programming approach using C. You can refer these books in your libraries. I think they are available. And now coming to the assessment for this semester for data structure, you can see you will have first internal it will be conducted for 20 marks and you will be having it for 5. It will be reduced to 5. Same way you will have second internal here. You will have second internal here. Second internal, this will be of 20 marks. It will be reduced to 5. Okay, and seminar and representation, seminar and presentations, you'll be getting 5 marks for doing that. And then assignment, project work, case study, you'll be having 5 marks. Whatever I have shown, everything is given in the syllabus copy. You can read it once. Okay, and after this we'll be starting with the lab programs that are prescribed in the syllabus copy by Bangalore University. Thank you.